Sea levels around the world have been rising gradually for centuries, with significant acceleration observed since the late 19th century due to global climate change and human activities such as deforestation and industrial emissions of greenhouse gases. The earliest known measurement of sea level changes came from tide gauge data in the mid-19th century, which showed an overall slight increase but without attributing it directly to anthropogenic causes. However, significant progress was made in the early 20th century with advances in satellite technology and global network monitoring systems, leading to more accurate measurements of sea level rise over longer periods. By the late 20th century, scientists had recognized that sea levels were rising at an increasingly rapid rate, primarily due to thermal expansion caused by ocean warming and increased melting from ice sheets and glaciers. Between 1980 and 2005, global mean sea levels rose at a rate of approximately 1.7 millimeters per year. This pace accelerated during the following decades, with sea levels rising at an average rate of about 3.2 to 3.6 millimeters annually by 2010. Multiple studies have quantified the impacts of this gradual rise on coastal communities and ecosystems worldwide. Coastal flooding frequency has increased in many regions, resulting in higher economic losses for property owners and infrastructure damages. As a result of saltwater intrusion into freshwater aquifers, millions of people around the world face reduced water availability for drinking and agriculture. The United Nations predicts that by 2050, approximately 40 million people could be displaced due to rising sea levels affecting coastal areas. While there are measurable benefits associated with addressing climate change and reducing greenhouse gas emissions through technologies like renewable energy sources or carbon capture, such actions also bring challenges related to job displacement in traditional industries. Moreover, some communities may struggle to afford costly adaptation measures aimed at mitigating the effects of sea level rise. Despite these drawbacks, early mitigation efforts have shown tangible results in slowing global temperature increases and reducing associated impacts on ecosystems. Looking towards 2050, continued global cooperation will be crucial for managing sea level changes effectively. Predictions suggest that with sustained reduction in greenhouse gas emissions and adoption of innovative solutions like coastal protection structures or artificial islands, it may be possible to limit future rises within manageable limits. However, without significant progress in addressing climate change, the likelihood of severe and irreversible impacts on coastal areas and livelihoods increases dramatically.